Welcome to The Explainer. Today we're going to pull back the curtain on a technology that feels, well, a lot like magic, machine learning. I mean, it really does feel like magic, doesn't it? That email promising you some big win just poof, vanishes into your spam folder. But here's the thing, it's not magic. It's a machine that's been taught to spot a trick. And today, we're going to show you exactly how that trick is done. You know, machine learning is pretty much the hidden engine of our digital lives. Just think about a Google search. In that tiny fraction of a second it takes to get your results, a machine learning model has already sifted through billions of web pages. It's not just looking at words, it's analyzing the connections between them to figure out exactly what you're looking for. Or hey, what about your phone's facial recognition? It's not just matching a photo, right? It has actually learned the unique geometry of your face. That's why it can recognize you in bright sunlight or a dim room, with or without your glasses, smiling or frowning. That right there is machine learning in action. And instant translation? Wow. For decades, people tried to teach computers grammar rules, and honestly, it was a total mess. Now, we just show them millions and millions of translated texts, and they learn the patterns all by themselves. They've figured out how to translate language the way a human would, by seeing it in context. Okay, so how does this magic actually work? Well, it all boils down to two key ingredients. And the first one, it's the fuel for all machine learning, data. Now, when we say data, please don't just picture neat little rows and columns in a spreadsheet. For a machine, data is anything and everything it can possibly turn into numbers to find a pattern. And just look at the variety here. We're talking images, video, even the text in an email, which a computer just sees as a string of characters. Then you've got these complex webs of connections, like in a social network, which it sees as a graph. To a machine, it's all just patterns and numbers. That's it. All right, the second ingredient is a really clear question. For our spam filter, the question couldn't be simpler. Is this email spam or is it not? That's it. This is called binary classification, and it's one of the most common tasks in machine learning. It's all about teaching a machine to make a simple choice between two options. Okay, so we've got our data and we've got our question. But how does a machine make an educated guess when it doesn't have all the facts? I mean, how does it deal with uncertainty? Well, it uses a very specific language for that, probability. And it all starts with a pretty simple idea, actually, a random variable. Just think of it as a way to translate the real world into numbers a computer can actually work with. So for a coin toss, we could just say heads is +1 and tails is -1. Boom. Now a coin toss is something a machine can do math with. And what this shows is that not all probabilities are created equal. Not at all. A fair dice roll, for example, is what we call a uniform distribution. Every single number has the exact same chance of coming up. But, you know, most things in life are more like a Gaussian distribution, which you probably know as a bell curve. Think about the height of people in a room. Most folks will be somewhere around the average height, with way fewer people who are super short or super tall. Okay, now let's really put probability to the test in a super high-stakes scenario. This is inspired by an example from our source material about medical testing. And this is a perfect case of where a little bit of information can be a very dangerous thing. So a positive test result, that seems like a sure thing, right? But it's not the whole story. A good doctor, or a good machine learning model, knows you have to combine that new piece of information with what you already know. For instance, if a disease is incredibly rare, a positive test result is actually more likely to be a false alarm than the real deal. This whole process of updating what we believe when we get new evidence, well, it has a name, Bayesian inference. It's all based on something called Bayes' rule. Think of it as the engine of learning. It takes what you already think, adds in some new evidence, and spits out an updated, smarter belief. This is really the heart of how machines learn. All right, it's time for the main event. We've got our ingredients, we've got data, we've got a clear question, and we have the rules of probability. Now let's put them all together and perform our magic trick, building a spam filter. This simple but incredibly powerful algorithm is called naive Bayes. And get this, it's not thinking at all. It's just counting. That's it. It looks at a giant pile of emails that we've already labeled spam or not spam, and it just counts how many times words like winner, free, and cash show up in each pile. Then, when a new email comes in, it just calculates the probability that it's spam based on the words inside. See? It's not magic, it's just math. Okay, so as we start to wrap this up, let's reveal the secret behind the magic trick
one last time.
So, the big takeaway here should be this. Machine learning isn't some mysterious black box of artificial intelligence. Not really. It's an incredibly powerful tool that's built on a foundation of some surprisingly simple ideas. And once you understand the ingredients, you realize the magic starts to look a whole lot like logic. And that leaves us with a final and, I think, really fascinating question. You see, all the machine learning we've talked about today is based on learning from the patterns of the past. But can we ever teach a machine to predict something truly new, something that's not already in the data? Now, that is one of the biggest and most exciting challenges in technology today.